Okay, so our video tonight is on fractional exponents, and put your date at the top. And we've talked in class a little bit today how all these square roots here are called radicals. And then this one here is called a cube root, because or the third root, because there's a 3. And this one is called the fourth root, because it's to the 4. Okay? So when we look at these types of problems, let's start with something we know. We talked about in class how this 25 is really 5 times 5, because it's 25, which is 5 squared, right? And this is the square root. So the base number here is my answer. So the square root of 25 is 5, because 5 times itself gives you this. Okay? And then the same thing's going to happen for a cube root. This was to the second power, so something times itself twice. This is a cube root, so we need something times itself 3 times to give us 27. And knowing multiplication, we can probably guess that's 3. 3 times 3 is 9, times 3 is 27. 3 to the third power gives me 27. Therefore, the cube root of 27 is my base number, or 3. Okay, so the cube root of 27 is 3, because 3 times 3 times 3 is 27. So the same concept is going to go down here with the fourth root. So I have to think of a number times itself 4 times. Well, it'll give me 16. So it's probably going to be a low number. I'm just going to guess it's 2. So we know 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's what I wanted. So 2 to the fourth power gives me 16, or the fourth root of 16 gives me 2. And same thing, if I had something to the sixth root, whatever it is, it'd have to be some number to the sixth power, or 6 times 6 times 6 times 6 times 6 times 6. Now going back to these roots, to the fourth root, we had to have 4 2's, right? Or 4 of something. For the third root, we have to have 3 numbers multiplied by itself. For the square root, we have to have 2 numbers. So really the square root has a little 2 here, but we don't write it, because it's just common knowledge that square, which is, if you think about the shape of the square, right, it's the same number times the same number gives you the area, right, which is why when we do this, we say it's 25 centimeters squared, because it's the same number times itself, and let's find the area of a square. Okay, so really this has a little 2 here, so I have to think about what number to the second power gives me 9, and then that should be 3. 3 times 3 gives me 9, so therefore the square root of 9 is 3. And really this has a little 2 here, so I have to think what number to the second power gives me 16. Well, we know that is 4. 4 times 4 is 16. So the square root of 16 is the base number 4. Okay. Now we're also going to use our calculators. Sometimes we get big nasty numbers, not nice perfect numbers like this. So if I look at my calculator here, and let's say I wanted to find this cube root of 27, I didn't know what it was, I would go to my math button, and I would go down to number 4, because it gives me the cube root. And then I put in my 27 here. And then that will tell me the cube root of 27 is 3. Now if I have anything over 3, I'm going to go to math here, and I want to use number 5 here. So it says x, which could mean any root. So I click that, and then I want to put, get me a little mistake on that, sorry. So this is, we are going to go to this math button here. It says the x, so we have to tell it which root we want it to be. So before we can do that, we're going to put that root in. So this is to the fourth root, so I'm going to put a 4 here. Then I'm going to go to math and go to number 5, because by putting the 4 here, I'm telling this is the fourth root. And then I put in 16, and then that'll tell me that I have an error and I did something wrong. What did I do wrong? Okay, not sure why that gave me an error, but just like I said, I want the fourth root, I go to math, I hit this one because I can put in any root, I told it 4, then I put in my 16 and I hit enter, and it's 2. Okay, so if I wanted to know the fifth root of something, oops, I would put in 5 for the fifth root. I would go to math, put in my number 5, and let's say I wanted to know the fifth root of 625. Just throwing that out there, no idea what it is. And I get 3.625. Okay? All right. So next we want to look at is when we have these fractions. Okay? So going back to my calculator, I can do this on here, but the problem is these types of problems are going to be inactive. See, I do it without the calculator, but I'm going to see if you can figure out what the pattern is here. So if I have 25 and I raise it to the 1/2, now in these older computers, I have to do a parenthesis to make sure that whole half is in there, okay? It gives me 5. Watch if I don't put the parenthesis in there. If I do 25 to the 1 divided by 2, I get 12.25 because it's taking it to the 1 power and then it's dividing this by 2. So if I want it to have an exponent of 1/2, it needs to be in parentheses, okay? So let's look at the 49 now. If I take 49 to the 1/2 power, what do you think is going to happen with that one? It gives me 7. Something's going on here. Hopefully you can see that really the square root of 25 is 5, the square root of 49 is 7, so when I have something to the 1/2 power, I'm really taking the square root of that number. And really what it means is this. Oops. So look over here. This number right here is going to be your exponent. So the numerator is going to be your exponent, and the denominator is going to be your root. So really what this is saying is we take the radical of 25, this is to the 1 power, and this is the root of 2. So it's saying what number times itself gives you 25, and that would be 5. Same thing here. This is my exponent of 49 right here. This is the root. So I have the square root of 49 to the 1 power, which hopefully we know is 7 times 7, which would give me 7 squared, which gives me a square root of 7. So same thing for this one. This is the root of 2. So I would have the square root of 225 to the 1 power, which is just 225. And so that, I believe, is 25 squared, which would give me an answer of 25. So here, now I have a different root. This is my root of 3. So this is asking for the cube root of 8 to the 1 power, or just 8. So hopefully we know that 2 times 2 times 2, or cube to the 3rd power, is 8. So the cube root of 8 is 2. Okay, so just take a minute to sort of digest that. All right, and so the opposite, we have to be able to do the opposite here too. So what I would do is go in and put 1s. These are all have an exponent of 1s. We're going to work with different exponents tomorrow night. So if this one wants me to put it back into the fractional exponent, I have x, the exponent of 1, and this is to the cube root. So this is really x to the 1/3. Okay? For this one, I have y to the 1 power to the 4th root, so that's going to be y to the 1/4. Okay? And so this is a, and we know this is to the root of 2, even though it's not written there. So it's going to be a to the 1/2. Okay? So try these little problems next, and we'll go over it in class tomorrow.